The dog is not enjoying that it's 30 degrees in the shop now, but that's just the way it is. So today's project has been a long time coming with this thing. It has a issue with the headlights, and from what I read, this is a pretty common deal. I don't know if it's just with the GMCs or if the Chevys have it too, but the way the headlights are set up on these GMCs is you obviously have 4 of them, 2 per side. And if I remember right, the outers are a low and high beam combo, and the inner is strictly a high beam. So when you kick this thing over to high beam, you get 4 high beam bulbs that come on instead of just 2. So the problem I have with this thing is this thing used to have pretty much one of the bulbs might have been original. It was still a T3, but it had old incandescent or whatever they're called bulbs in it, and everything was fine. But as I've lost bulbs and I've had to put these halogen ones in it, just because that's the only thing available to me on a day's notice, it will trip the circuit breaker in the headlights. And yes, circuit breaker, not a fuse. And I think the reasoning for that is if you're going down the road, highway speeds, pulling a trailer, road conditions are not great, a little windy or something like that, and you lose headlights, you have a huge problem. So what they did is they put a circuit breaker in the power feed for the headlights. I think it's in the headlight switch instead of a fuse. That way, if something goes wrong, the truck will do everything it can right up to burning itself to the ground to keep your headlights on. So in my case, it would trip the circuit breaker after about 5 to 10 minutes of driving, just because it was barely too much. It was just slowly warming that bimetallic strip up, and it would cut the headlights out, bring them back in. Off, on, off, on, off, on. And it would just sit there and start flashing the headlights on and off. So the best fix I can come up with for that, given that I want to be able to just, keep putting headlights in it the way that I have been, is I'm going to get a separate power feed ran over here, and I'm going to put the high beams on their own relay. So I'm just going to mount it over here. I'll go over that later. But so far, what I got going right now is got some of this mess torn apart. This green wire right here is the wire that comes from the floor-mounted high-low switch. So this green wire is the power for the high beams. I'm going to leave the low beams on the factory wiring and not mess with that, since that should be the most reliable setup, and I'd rather not mess with the headlights that I use almost all the time. But I'm fine messing with the high beams because basically it's just going to be 2 different headlight systems. I'm going to use this green wire that used to power the high beams. I'm going to cut it here, and I'm actually going to use it as the signal wire to trip a relay, and then I'll run a dedicated power feed over from the battery to said relay to run the high beams, and I'll put a 20 amp circuit breaker in there for the same reason that the low beam has a circuit breaker. So step 1 here is find where all of the high beam feeds are crimped together. So that is right here. This should be a factory crimp solder job. So this is the power feed coming in, and then right here, these 2 are for the 2 driver's side bulbs, and then this one back here runs across the core support to the passenger side bulbs. So if I just throw my relay in here into this wire, I haven't really solved anything because I've protected the wire upstream of the relay, but all of this wire here is still pulling the same current that's tripping the headlight switch, or the breaker in the headlight switch. So what I need to do is I also need to separate these power feeds out where they're not all relying on each other. So for the power feed, I obviously have a side post battery in this thing, so bolting up to the actual battery is not really a convenient option. But what I do have is this big fuse down here that basically protects the alternator from, I guess, blowing up the battery or putting way too much power to the battery. So I've been using just these studs as junction blocks basically, and I just added another power feed coming right off of this guy. So this is 12 volts straight from the battery and alternator. and it's not switched anywhere because there's the battery cable and it loops around to that side, I think. And then this side has the alternator coming off of it. So power feed, it just runs all the way across to over here. And this brown is my 12 volts from the battery. This littler green wire is the original high beam wire. So this I'm just going to use as a signal to close the relay. This 12 gauge green wire, this brown is also a 12 gauge. So the power feed is 12 gauge, which should be way more than enough. This green is 12 gauge. And what I did is, well, it's kind of hard to see. Anyways, what I did is I took this 12 gauge and I took the three headlight wires, because there's one for that bulb, the second one's for that bulb, and then there's one that runs all the way across the core support. I took the three of those and soldered them all together to this one 12 gauge wire. So that's how I reduced the load on all those other wires. So the wires going to these two bulbs, obviously they're just supporting the one bulb they're tied to. The wire that goes all the way across the core support has to support two bulbs, but that'll be fine because, I mean, originally it was just the one wire that runs out here to this junction that was supporting all four of them. So I've at least halved the load on the factory wiring, which is what I wanted. And then I upgraded this to the 12 gauge just so I don't run into the exact same problem that I had before. And then this black wire is just the ground for the coil of the relay, and I just grounded it right there because I already had a ground there. So in summary, power is going to come in through this green wire, which used to be the factory high beam power. This is what's coming from the high low beam switch on the floor. That power is going to go through the coil of the relay, and it's going to leave the relay through this ground. That's going to energize the relay, cause the contact to close. When the contact closes, it's going to switch power from this 12 gauge wire coming from the battery. It's going to connect power from that to this green 12 gauge wire, which then splits the feed to all four headlights. So here is this, just before I go ahead and put it together. So I had this metal bracket, so it actually ended up being pretty well perfect for this. Just bend up any piece of metal really, just something similar, or just mount everything separately. But I put the circuit breaker down here. I went with a 30 amp self-resetting circuit breaker. So it's going to be mounted directly below the relay, so it's obvious what it is. It comes with this little rubber cap that goes on it so that it can't touch and ground on anything, which is good. And it only just occurred to me that I got a little excited by my new heat shrink crimp deals, because I used those instead of using the plug that came with the relay, but not a big deal. I'm pretty happy with how this turned out. So I'm going to go ahead and just mount this to the inner fender here, kind of similar to that guy, and then we'll do a test of it. There's the relay installed. Feel pretty good about it. Looks pretty clean. So go ahead and turn the lights on for a while and make sure nothing trips out. Well, I think that's going to do it for this one. Nothing is tripping. The factory circuit breaker is fine. The one that I installed is fine. So the 30 amp circuit breaker I installed seems to be rated high enough to carry the load of all four headlights. So everything seems good. They honestly might even be just a little bit brighter than they were before too. So that's kind of nice. Overall, I'm really happy with that. Everything seems cool. No issues with it. So ought to be a lot better driving it at night now that I can actually use the high beams again.